One of the toughest things we've done so far is the Mobius inversion formula, and I thought it was worth going over it slowly to give you something you can refer to when the notes are starting to confuse you. So I've got a couple of reference things here already on my page. In the top right, the mu function, which is always a little tough to remember, so I've got that written down. And then we've got the Mobius inversion itself in the top left here in blue. So what this is in its most basic form is when you have a function f that's created from a function g, you can reverse it. You can write it in such a way that g is a function of f. This is like a little like rearranging functions when you were in grade 7 or 9 or 11, whenever that happened for you. But it's a much more complicated type of rearrangement. So we can have any function g that we want. Say our g is something pretty typical that you might have seen a million times. It's just something you do with the input number. So g of x, let's say, is x squared plus 1. And our f of n always has the same form. This isn't very general. It's always one particular thing that you do with it. So if our function f is created by taking g of the divisors of n, then that's a new function. So for instance, my g of x here, let's say we're going to apply it to n equals 6. The divisors of 6 are 1, 2, 3, and 6. So f of 6 would be the sum over the divisor, so it would be g of 1 plus g of 2 plus g of 3 plus g of 6. And g of x is just x squared plus 1, so we can figure that out. G of 1 is 2, g of 2 is 5, g of 3 is 10, g of 6 is 37. 47, so that's 54 if I've done that properly. So we have f of n directly, but what if we want it in the second form, this g of n equaling some function of f of n? We want to turn it around for some reason. We do that by just writing it in the new way. G of n is the sum over the divisors of n with this mu function that makes it all work. And we have to do f of n over the divisors. So using our favorite n of 6 again, let's see how this works. We want the sum over the divisors, so that's 1, 2, 3, and 6. So it's mu of the first divisor and f of 6 over the first divisor, plus mu of the second divisor, f of n over the second divisor, mu of the third divisor, f of 6 over 3, and then the final divisor. Just fits. Now's where we need to remember how to use the mu function properly. So mu of 1 is always 1, that's no problem. This is going to be f of 6, so let's just write it like this for a moment. Mu of 2, because 2 is one distinct prime. Mu of 2 is negative 1. And this will be f of 3. And this is a common mistake that students make, is to forget that we're dividing these here. It's not mu of d, f of d, it's mu of d, f of n over d. They kind of match up, but not in the way you expect. Mu of 3 is also minus 1 because it's one distinct prime. And that's going to be f of 2. Mu of 6, 6 has two distinct primes, 2 and 3, so that's negative 1 to the power of 2, which is just a 1 this time, f of 1. Now our f function is a little complicated, but we did some of it already. We already know that f of 6 is 54. and this is going to be a minus f of 3. We just need to remember what g of x was, because f of 3 is the sum over the divisors of 3 of g of the divisors. So it's, the divisors of 3 are 1 and 3, so it's g of 1 plus g of 3. G was our x squared plus 1 function, so it's 2 plus 10, so f of 3 is 12. Got another negative here. F of 2 is the sum over the divisors of 2 of g of those divisors, so that's g of 1 plus g of 2. 1 squared plus 1 is 2, which is 5. And f of 1 is 2. So let's see if I've done this correctly. 54 minus 12 is 42, minus 7 is 40, 35, plus 2 is 37. And g of 6, we calculated before, it is in fact 37, because it's 6 times 6, which is 36, plus 1. So we got a little bogged down in the details there, but what you can see that we did, hopefully, is that we took a function of f that was based on g, we turned it around so that we had a function for g directly in terms of f, and then we confirmed that our function worked by figuring out g of n. We only tested it for one specific example, but that's enough for what you need to do right now. So I hope that helps. Go through it slowly. You can keep pausing it, take notes, and my next video will be the example from the tutorial that we did, I think, in the second week. Bye for now.